P&Q?
Yeah.
When I go run errands and look on the ground or a sidewalk, cigarette butts are everywhere. Right there with leaves, twigs, wrappers, and bottles. However, appearances are peanuts compared to what they do when they break down into smaller microscopic plastic chunks. I don't claim to be an expert, but I've read that it can be pretty gnarly. And from there, the imagination kind of takes over, and I can't help but think what path the microcrab takes downstream into the food chain, the environment, and ultimately us. When I first met my wife, I was taking a class on landfills. The science and logistics behind what it takes to run a landfill was quite fascinating. I struck up a conversation with my not yet wife on a short 15-minute break at work. I don't remember specifically what I told her about landfills, but whatever it was landed me a first date. It just goes to show that we were destined to put our minds to the challenge of solving cigarette butt litter. Our goal: to create a robot that automatically detects cigarette butt litter, picks it up, and collects data about where the problems are. This is the first time we tested both tracks with the motors attached. The brains are an Arduino Uno gifted to me by my bro for a birthday. The Arduino is hooked up to a motor controller chip to control the direction and speed of the two motors. And we have a separate power supply for the motors themselves so that they get enough juice. We got the tracks printed at our local library since we don't own a 3D printer ourselves. It can take a long time, and sometimes they forget to print a specific piece. So in addition to the 3D printed pieces, we are using foam board to prototype. It is easy to cut and rigid enough to hold the components roughly where they need to be so that the tracks can carry them. Here I am struggling to open a box. This is our new Arduino Giga. We were running out of pins on the Uno, and it won't have enough processing capabilities for the AI we'll need later on. The Giga has way more pins, onboard Wi-Fi capabilities, and the ability to run TinyML, a machine learning language that will run on such a tiny scale. We ran into a lot of issues trying to get the tracks to work as we learned more about the various components in use. But we were finally able to get them to go in all the directions needed and control via Wi-Fi no less. A friend gifted us some Lego Technics to prototype the arm and claw with, and we came up with a design we really liked. But the downside is that the Lego is pretty heavy, which will require beefier motors. So to lower the weight of the arm, my wife had an idea to use an unconventional method, at least to my knowledge, and used paper. We printed the design onto cardstock and then glued two pieces of cardstock together for added strength. We brushed the glue thin to keep the paper from warping, and then added some dictionaries to weigh it down for good measure. Next, we used a craft knife to cut it out as precisely as we could. Each piece is labeled to make it easy to identify or make modifications in case we needed to. By using a straight edge, we were able to fold the paper more exactly than if we were to do it by hand. Then we attach the motors and glue the edges of the paper together. It makes a nice stiff little box that should be able to support a claw that can pick up cigarette butts. Time to test. We also added some software improvements to Guzman GIS, the software we built to visualize the map data for the robot. Our new feature, using GPS to tag points of interest by pressing only a button. We'll need this to be able to visualize the geolocation data later when mapping where the cigarette butts are. All you need to do is load up the site on the phone and head out. Our idea to test a new functionality, we had the brilliant idea of making a map of our standard dog walk, and just for fun, marking each spot where our sweet little puppy goes number 2. We scaled the data to fit, and drumroll please. Complete chaos. The location data we captured isn't quite accurate enough to work on a small scale. We have some ideas for next steps to improve this, but in the meantime, it's a little bit of a mess. The user interface on Guzman GIS is one that I'm proud of. I'm constantly making improvements, and I'm open to making it better. I chose this design because I wanted the menus to be seamless to use on both mobile and desktop. Here you see me demoing Guzman GIS as if I were adding points of interest inside a house. editing the data within the map view, and showcasing how easy it is to make fine-tuned modifications from the table view. Time to put this robot to the test. Alright, I'm connecting, and what do you want me to do?
Try out some commands. Go backwards more.
Goes backwards.
Backwards isn't working, okay.
P and Q?
Yeah.
Forward, backward, left, right, forward, backward. So we still have some problems. The tracks work great when they aren't on the ground, but with the full load of the robot, we still have some issues. A lot of Googling later, and we think we found a solution. A new part is on its way to hopefully solve the problem. So where are we? We have somewhat functional tracks, a mostly functional arm. It just needs to get properly attached, and actual functional Wi-Fi control. Next, we need to fix the tracks so that they can properly carry the robot around, get the claw working, and contain the wires so that we can take the robot for a field trip and test it out. We post monthly updates to this channel, but if you can't wait to see what happens next, join our Patreon. We post weekly updates and more detailed information about our process and problems. Or you can always like, subscribe, or comment too. Any way you support this project helps us get closer to a future with less pollution.